So if we add acid, we need to know if our anions in solution are basic. So let's kind of go through an example, and we'll kind of pictorially represent what's going on in these cases. If you look in your lab manual, I really like the figures that we've put together in the background of the qualitative analysis scheme, and it'll really help you guys to visualize what's going on. So the example question that we're going to look at is, how does adding HCl or NaOH influence the solubility of magnesium hydroxide? So one of the things that I'm really going to emphasize, and I'm going to write this in big letters, is we need to write out the equilibrium expression. This is very, very important in terms of understanding what's going on at the molecular level. So we have magnesium hydroxide, which is MgOH twice as a solid, in equilibrium with Mg2 plus in aqueous solution plus 2 OH minus ions in aqueous solution. The question is, what happens to this equilibrium and this species when we either add HCl or NaOH? So if we had a beaker of a saturated solution of magnesium hydroxide, think about it as we have the solid, which are these close-packed ions held tightly together. That's going to be in equilibrium with the magnesium 2 plus and the OH minus. So we have a dynamic equilibrium taking place here. If we add HCl, remember HCl is a strong acid, so in solution it's going to give us H plus ions plus Cl minus ions. So if we add HCl, let's think about what happens in this particular case. So we have this beaker that now has Mg2 plus ions in solution. We have OH minus ions in solution. We have H plus ions in solution. And we have Cl minus ions in solution. So then we have our solid down here at the bottom of the test tube. And we have an equilibrium. Le Chatelier made a bunch of observations and said what happens in solution when we manipulate an equilibrium expression. Or the wording he used was, when an equilibrium is disturbed. So what we're doing in this case, and this is the reason in the first lab where we hammered you with all these pre-lab questions about really understanding what a saturated solution is. Because with the foundation of a saturated solution, we can now see what happens when that solution becomes changed. So in this particular case right here, we're adding H plus and Cl minus. The question is, what happens to the species or the ions that are above this solution? If you have an H plus ion, which I've drawn down here, and an OH minus ion, they're going to neutralize each other out and they're going to form water. So what happens is we have this neutralization reaction taking place, and in that neutralization reaction we are taking OH minus ions out of the solution. So the concentration of OH minus ion is going to drop. Since we've written out the equilibrium expression, we can see that the OH minus ion shows up over here on the right-hand side. If we drop the concentration of OH minus ion, or if we remove OH minus ion from the solution, that means our equilibrium is going to shift to the right. If this equilibrium shifts to the right to account for this change in the saturated solution, or by disturbing this equilibrium, this is going to shift forward. So what's going to happen is, once this H plus neutralizes the OH minus, one of these OH minus ions here in the solution is going to dissolve and maintain that equilibrium. This is going to be dictated by the equilibrium constant, but in each case, when we add an acid and neutralize that OH minus, it's going to start to dissolve. Same principle happened when we had the calcium iodate. If there's calcium iodate solid in there, and we remove something over here on the right-hand side in solution, the equilibrium is going to shift to the right, and the solid is going to begin to dissolve. So in this case, when you add an acid, it'll neutralize the OH minus ions, and we'll get a scenario over here that we'll have water as a product of the neutralization reaction. We'll have magnesium 2+, we will have Cl-, we'll have some OH- after everything is neutralized, and we'll have not quite as many solid particles in solution, or at the bottom of this beaker, okay? Because since the equilibrium got shifted, more of those particles are going to dissolve. So what we can say from all this, if we summarize this up into a statement, is the statement that you typically see in your textbook or your lab manual. So what we can say is that adding HCl neutralizes the OH- ions in solution and shifts the equilibrium to the right, since the concentration of OH- has dropped or has lowered. As a consequence, the physical evidence that we have of this is now that the solubility of magnesium hydroxide, or MgOH2, increases in acidic solution compared to an aqueous solution. So the more acidic we make this solution that we're dumping the magnesium hydroxide into, the more soluble it becomes. I'm not going to draw out the figures for this, but I'm going to make another statement about what would happen if we add NaOH. So if we add NaOH, this is essentially the same thing that we could look at, or it's the same principle that we see for the common ion effect. So by adding NaOH, we're producing Na plus ions in solution plus OH minus ions in solution. So we are increasing the concentration of the OH minus. If we're increasing one of these concentrations, or one of the concentrations of the ions that we have in solution, this will shift the equilibrium over to the left, or to the reactants, which is the solid in this case. If we shift that equilibrium over to the left, as a consequence, the solubility of MgOH2, or magnesium hydroxide, decreases in basic solution. So as we vary the pH, we can vary the solubility of this particular salt. In this case, magnesium hydroxide. So from this standpoint, we have our magnesium hydroxide. We looked at it and we approached this from a common ion effect, looking at Le Chatelier's principle. How is the equilibrium shifted? Is it shifted to the left? Is it shifted to the right? And how can I manipulate that by adding a common ion or removing one of the ions in solution? So this is the straightforward, easy analysis that we have. But typically, what we find is some other things happen and some crazy stuff happens in these aqueous solutions.